Hello there. We're looking at pages 238 and 239, divisibility rules. So, tell whether the given numbers are divisible by 2, 3, 5, 6, and 10. Write an X in the table to show that the given number is divisible by 2, 3, 5, 6, and or by 10. So the first number is 27. 27 is an odd number. Remember, odd numbers end with, well, hello, that was a mistake, I apologize. Odd numbers end with 1, 3, 5, 7, or 9. And even numbers end with 0, 2, 4, 6, 8. 27 ends in a 7, so it is an odd number, so it is not divisible by 2. So let's leave that spot blank. Now, is it divisible by 3? Okay, the rule was, if you can do the digits, 20 plus 7 is 9, and 9 is divisible by 3 evenly, then yes, it's divisible by 3. Is it divisible by 5? Well, the rule was, if the last digit was 0 or 5, it was divisible by 5. So no, it's not divisible by 5. Is it divisible by 6? If it's divisible by 6, then it's divisible both by 2 and by 3. But 27 is an odd number, so it's not divisible by 2, so it's not divisible by 6. Is it divisible by 10? It doesn't have a 0 for the last number, so no. That one's only divisible by 3. Let's look at 365. It's an odd number, so it's not divisible by 2. No. Is it divisible by 3? Well, let's add 3 plus 6 plus 5. So that's 9 plus 5 is 14. 14 is not divisible by 3. 3 times 5 is 15, but 14 doesn't work. So no. Is it divisible by 5? Yes, because the last digit is a 5. It's not divisible by 6. It's an odd number. It's not divisible by 10. It doesn't end in 0. This is an even number, so it's divisible by 2. Is it divisible by 3? 4 plus 0 plus 2 is 6, and 6 divided by 3 equals 2, so yes. So we know right away that it's also divisible by 6. Not divisible by 5, not divisible by 0. 115 is an odd number, not divisible by 2. So 1 plus 1 plus 5 equals 7. 7 is not divisible by 3. It is divisible by 5, but not by 6, and not by 10. 782 is an even number. 7 plus 8 plus 2. 2 plus 8 is 10, plus 7 is 17. 17 is not divisible by 3, not divisible by 5, or 6, or 10. 960 is an even number. 9 plus 6 plus 0 equals 15. 15 is divisible by 3. It's divisible by 5 because it ends in 0. It's divisible by 6 because it's divisible both by 2 and by 3. And it's divisible by 10. So 960 has all of them. Let's check and see what's on that next page. Prime factorization for large numbers. Use divisibility rules in a calculator to find the prime factors. So, what do we know right away by looking at 108? 108 is even, so it's divisible by 2. And we also know that 1 plus 0 plus 8 equals 9, so it's divisible by 3. So we know it's divisible by 6, because it's divisible both by 2 and by 3. So I want to use 6 right there, and then I'll do 108 divided by 6. 1, 6, 4, 8, and that's going to be 18. And we can break 6 into prime factors, 3 and 2, and 18, 2 and 9, 3 and 2 and 2 are all prime, and 3 and 3 are prime. So now let's write the prime factorization there. We've got 2 times 2, and that is these two factors here, and then we've got 3 3's. Times 3 times 3 times 3. So this right here is the prime factorization for 108. Here's another way you can write it. Because there are two 2's, you put an exponent of 2 right above that. And because there are 3 3's, you put an exponent of 3 above the 3. Just like that. Now let's work 300. We know it's divisible by 10, so let's just use 10. And then these are composite numbers, so let's break them into their prime factors, 2 and 5, 3 and 10, and 2 and 5. Is that the last problem? Nope. So let's count how many 2's. Those are prime, and there's 2 of them, so 2 times 2. And at 3's, there's only 1 3, and there's 2 5's. Oops. And then again, you can write that. Because there's 2 2's, you use an exponent of 2. There's only 1 3, and there's 2 5's. So those are both ways to write prime factorization for 300. 135 is our last one. We know it's divisible by 5 because it ends in 5. 1 plus 3 plus 5. That's going to be 4 plus 5 is 9. So that's also divisible by 3. But since it has a 5 in the last digit, I know it's divisible by 5, so I'm just going to use 5. And do 135 divided by 5. 2, 10, 3, 27. 5 is prime, 27 is composite, 3 and 9 are factors, 3 is prime, 3 and 3 are factors, so we have 3 3's times a 5. Or you could do 3 to the third times 5. Either of those are correct for prime factorization for 135. Thank you for the work. Whoops.